Today we're going to be measuring distances with only a camera. Hey guys, what's up? Hope you are doing great. A while back I took this long exposure photo at night, and I thought it turned out pretty cool. A plane was flying over, so you could see like the big light streaks of the wing lights and all that stuff. And as I was editing that photo, I thought how cool it would be to measure the distance to that plane, or the altitude of that plane. I was wondering, I wonder if there's a way to do that. So I did some research, and turns out some people a lot smarter than me came up with some equations to be able to measure the distance to an object from a camera. So I thought it would be cool to go ahead and make a video about it. Now this video is going to actually be split up into two parts. The first part is going to be talking about the math behind it and actually how to code a bit of a application or script to run on your computer to run that code, which is specific to your camera. And then this part two will be us testing the camera and testing the code to see how accurate it really is. Now, if you don't want to do any coding or math, that's totally fine. You can just go ahead and skip right to part two, which will be up here. This video is just for those who are interested in the math and want to learn how to code a quick and simple script to run it. But if you don't want to do that, that's totally fine. Just go ahead and watch part two, and you can just use one of the online calculators. All right, so first off, let's go ahead and look at the equation to calculating the distance of something by taking a photo of it. Now it is a bit more complicated than just snapping a photo of something and instantly knowing its distance. There is a bit of work involved, and you have to know at least a couple things. But let's go ahead and look at the equation. I'm going to read it because I haven't memorized it. So the basic equation is distance to object equals the focal length times the real height times the image height over the object height times the sensor height. So for this to work, we need to fill in each one of these variables on the right side of the equation to get the distance. So let's go ahead and go through each one of these variables and talk about knowing each one. First off, the focal length, that's the focal length the photo was taken at. So if you're using a DSLR, that should be really easy to find out. If you're using a prime, then you know your focal length. If you're using a zoom, take note of what focal length the photo is taken at. Next is the real height. This is the real height of the object you were trying to find the distance to. This equation really is dependent on each one of the variables being accurate. So the less accurate all of your input variables are, the less accurate the answer will be. Next is the image height or image size. This is basically just the resolution of the photo. We also have object height in pixels, meaning that how many pixels the object takes up in the photo. And lastly, you have sensor height or sensor size. This is just the physical size of your camera sensor. Now, as you can see here, we're using height as our example in the equation, but you could use width as well if you want to measure how wide something is. And I suppose you could do diagonally as well, although that would be much more difficult because you don't have a square sensor. So it'd be a lot more complicated to work out. I would suggest looking into it because that could be really interesting. But in this video, we're just going to talk about width and height because that's really simple to do. The basic rule here is if you're measuring width, make sure all of your variables are in the width format, and if you're measuring height, make sure all your variables are in the height format. I left a link down in the description to a page that explains all this math in much more detail, as well as a calculator. So if you want to do some other types of things than what's shown in this video, go check out that link because there's a lot more information there. Alright, so let me go ahead and show you some code that I've written that I'm going to be showing you how to write today so that you can have your computer run all this calculation and you don't have to do it yourself. The language I use is bash, which is basically a set of commands that can run in a shell, also known as a terminal or a command line. And these are great because they can run on any system, so the code itself won't change. The formatting of the document changes depending on what system you're on, but the code itself will be the same, so that's really nice. So let me go ahead and run the script so you can see what it does, and then we'll get into how to code it. So the script is in the format of a .command shell file, so I'll go ahead and double click it, and it will open up a terminal window, in which it will ask me a question, what is the focal length of the lens? In which case I'll input the variable, let's say it's 55 millimeters. Focal length set to 55 millimeters. Now are we measuring the height or the width? It's going to ask that, so then we're going to say, let's say we want to measure the height. So I'll type in height. So it says measuring height. Okay, now it's asking what the object of the height is in millimeters. So let's say my object is 20 millimeters tall. And then what is the object height in pixels? Meaning in the photo, what is the distance between the two edges that I'm measuring? So I know that that is 618 pixels in the example photo. And then it can see here, it gives us the calculation. The distance to the object is 412 millimeters. So as you can see, it's just a quick terminal command line that asks you some questions, you put in the variables, and it does the rest for you. And the whole reason we would use a script like this rather than an online calculator is that it's a lot faster. You'll notice that we only entered 3 variables when in reality we need 5. That's because 2 of the variables are going to be the same as long as we're using the same camera and shooting the same resolution. So because of that, I can have those already built into the script. So when I want to do more calculations, I can just pull up the script and not have to type in extra variables that I don't need. All right, so let's go ahead and get into programming this. First off, you're going to need a text editor. I highly recommend Atom if you're on Mac. Notepad++ is a great one if you're on Windows, and Linux, got no clue. But really any text editor should work. I just prefer using Atom because it is made for programming, so it color codes different things. It's just easier to work with. So go ahead and create a new file in your text editor of choice. And before we even start programming, I'm gonna go ahead and save it as, and you can name it whatever you want. We'll call it tutorial script. And this is the important part. After the name, make sure to type .command if you're on a Mac. If you're on Windows, you can name it .sh for shell, but since we're doing a Mac, I'm gonna name it .command. Okay, go ahead and get settled in because we have a decent amount of code to write. But if you follow along closely, it won't be that hard. And if you have any questions, ask them in the comments, or if you want a quick answer, just Google it because Bash is a pretty simple coding language. Lots of people use it, so most of your questions can be answered on forums and stuff like that. All right, at the very top of the document, we're going to add what's called a comment. So we're gonna do that with a hashtag, which means that this will be ignored by the command line. And then we're gonna type !bin/bash. All right, next I'm gonna go ahead and paste a bunch of text. You can copy this text down in the description if you want. These are basically just a bunch of variables that will allow us to change the color of text throughout the rest of our document. I could go into this, but honestly you don't need to know it because it's completely irrelevant to the actual math itself. Next, we're going to declare a whole bunch of variables, and I'm gonna comment this and call them reference variables because there are going to be a whole bunch of information about our camera that we're going to reference throughout the rest of the script. First off, we need a sensor height. So we're going to type sensor height, and then we're going to make that equal to your sensor height. So look up the sensor size of your camera. It needs to be in a width times height format, not a diagonal, very important. So go ahead and type in your sensor height in millimeters. By the way, all the distances we're doing in this entire math, it's all going to be in millimeters. Next, you're going to type sensor width and do the same thing. Next, we're going to create 2 more variables called image height and width, which is the same thing, only it's going to be the resolution of the photos. All right, now that we've established all our variables, we can go ahead and start the actual code. The first one is going to be a terminal command called sleep, which is basically just means don't do anything for this amount of time, and in Mac it's taken in as seconds. So we're going to say sleep 0.5. I'm going to add a lot of sleep commands in this script. They're not really required. I find terminal works better when you don't shove a lot of commands at it really fast, and it just kind of is easier on the eyes not to have a bunch of text popping up really quickly. But again, completely my opinion, you don't need this at all. All right, first we're gonna ask the user for a focal length input. And for that, we're gonna type echo-e. Now, the echo is a command that will just type something into the terminal, and the -e will allow us to use color codes that we defined earlier. Then in double quotes, we're going to type what we want to say. So we'll have it say, what is the focal length with a question mark. All right, but we want to go ahead and color code this. So to color code it, go to the beginning, and we're going to add a $, which in Bash just means that we're about to reference a variable. And then we're going to do open curly bracket and then type the color that we want. So let's have it be green. So we're going to do all caps green and then close that curly bracket. So what this does is it references the green variable that we established earlier, and which will just tell the echo command to make this following text green. Next, we're going to use the read command to get input from the user, and then we're going to pass whatever they type in to a variable. We'll call the variable focal length. Now whatever the user types in will be passed on to the variable focal length. Now we're going to ask whether we're measuring in height or width. So again, you can just copy the previous command or echo, paste it in, and change the text to measuring in height or width as a question. Now, technically, we don't need this green in echo whenever we pass a color to the echo command. All the text after it will be green until we tell it otherwise. So now we're going to use read again to pass whatever they type in, height or width, to the variable measure type so that we know what type of distance we're measuring. All right, now we're going to create our first if statement, and actually our only if statement in this document. So in Bash, create if statement, just go ahead and type if, then open square bracket, and in here we're going to put in our parameters. So our constraints are going to be take that measure type, so quotes, $ measure type, and we have to put this in quotes because the measure type is a string variable, not a numeric variable, because they're going to be typing in text. Then we're going to put an equal sign, and then in quotes type in height as our first thing. So basically what we said here is if measure type, what they typed in earlier, is equal to height, then do the following commands. And below that, of course, you have to type then and then hit return. For right now, we're going to leave that blank and continue on with the if statement. So next we're going to type elif, open brackets, and do the same thing. So call upon that measure type variable, but this time we're going to ask if it's equal to width. Put another then under that. We're going to type else, because if the user types in something other than width or height, we're going to throw an error at them and say, no, you have to type in either width or height. So below this, we're going to go ahead and say echo -e, and we're going to have it say error, invalid syntax to sound fancy, or we'll do invalid string. That makes more sense. You don't need to do this, but this is useful for if something goes wrong and it just quits, you don't know why. This way, you know why. Okay, so let's go ahead and make that in red too. So we're going to go ahead and add $, open curly brackets, red, close curly brackets. Then below that, go ahead and type phi to end the if statement. Also, make sure if statements have a space after and before each bracket, because if they don't, it will throw an error at you. I totally didn't just find that out. Before we go on, let's go ahead and run our code just to make sure everything works. It's best to run often after you change things rather than change a whole bunch of things. Run it, and if it doesn't work, you have no idea what's going on. So if you navigate to your script that you made and double click it, you will notice that nothing happens, or you might get an error. This is because we have not given the file privileges to run. So to do that, open up terminal and go ahead and type chmod a+x, and then go ahead and just drag in your file or manually type in the address of the file, hit enter, and nothing happens, but actually we've just given privileges to that file to be able to run. So if you run our script, as you can see, it runs, asks what the focal length is. Let's say it's 25 millimeters, and it's asking whether we're measuring in height or width. Let's say we accidentally type it wrong and spell it wrong. It's going to throw an error at us, say invalid string, so that means our code is working. But as you can see, after the error invalid string, it made the rest of the text below it red. And that's because down here we did not tell it to change back to normal color or no color. So at the end of this invalid string, let's go ahead and add a color variable and make it NC for no color. That way everything after that doesn't have a color. Also, let's go ahead and make all of our inputs blue. So to do that, we're going to go up, and right before the read command in the echo right before it, we're going to add a color variable, and let's make them blue. Do that for both of them. And this way, after that echo ends, the next text that's typed will be in blue. Now let's go ahead and code the height section of the if statement. First off, we can go ahead and delete this. Then we're just going to type another quick echo command just to confirm that we're measuring height. So I'll just have it say measuring in height. Just so we'll say measuring height, just as a bit of a confirmation. And we'll go ahead and make that green like the rest. We can go ahead and copy and paste this below. And in this second echo, we're going to ask what the height is in millimeters, so what the actual object height is. So we're going to say, what is the object height? And we'll put millimeters here just so we know what they're asking us to do. And then we're going to pass what they type in. And we'll pass it to a variable called object height and millimeters. Then we can go ahead and copy these two lines, paste it again, only ask for the height in pixels, and change the variable to px for pixels. And now we have all the necessary variables to complete the calculation. So we're going to add another echo command, and we're going to have it just say calculating. And we can also use our variables to make text bold, not just colors, so we can use the bold variable to make it bold. And then after that, we'll add a normal variable to make the text go back to normal. So now we're going to go ahead and form the equation to calculate the distance. So to do that, we'll make a new variable called distance, and we need to make that equal to another variable that will be defined as all the math. So we'll go ahead and type a $, then open parentheses. Then in here, we're going to type BC, and then 3 less than signs, and then all the math that goes into the equation. The reason why we're having to do this rather than just typing the math in by itself is because the math uses floats, which, if you don't know, are just decimal values, and Bash does not have the capabilities of calculating float values, so we're having to use another program called BC to run all those calculations. Now you do need to make sure that BC is installed on your computer. It should be by default, but just to double check, go ahead and open up a new command line and type in BC, and if you get some information about the copyright information and the version number, it means it's installed. If not, Google how to install BC terminal. Alright, so inside these parentheses, we're going to add some quotes with another bit of parentheses, and then here we're going to type in the equation. So our first variable is going to be our focal length, so go ahead and type that in, and then multiply that by adding an asterisk by the next variable, which is going to be our object height in millimeters. Next, we're going to multiply that times our image height. Now go ahead and go outside of those parentheses, add a slash for divide, then create more parentheses. Inside of these parentheses, object height in pixels by the sensor height. Alright, now that is all the math. You really will want to go through and double check that all of this is exactly how it is in the equation, because if not, nothing is going to work right. Alright, now that we have this distance variable holding the distance value, we need to go ahead and print that to show the user. So we're going to go echo -e, and inside the quotes we're going to make the text green again, which it probably already is, but just to make sure. And we're going to say the distance to the object is colon. And before we go ahead and call upon the distance variable, we want to go ahead and make it a different color so it really stands out, so that you can tell what's what. So we're going to make it purple, and we'll also make it bold. Next, go ahead and just type the distance, but we want to add millimeters on the end of that distance and make it print millimeters. But if we just type mm, then it will think that the variable is called distance mm, which it's not, of course. So to fix this, all we have to do is what we've been doing with all the other color variables, and just add curly brackets on either side of that, and those curly brackets just say the variable name is only inside these curly brackets. Anything to the right of these curly brackets is not part of the variable. So we can do that, and as you can see, the mm turns back to green, signifying that is going to print it as an M. Alright, now that is all the code for the height section. Now we want to go ahead and do all this again for the width section, but we don't need to type it all out again. Instead, we can just go ahead and copy and paste it into the width section, but we do need to make sure we go through and change every height to width, otherwise it will not work. And you definitely will also need to do that inside the equation itself. In fact, that's the most important part. As a final touch, I am going to add an extra sleep 0.5, just so we have a bit of time there. And that is basically all the code you need for the script. So let's go ahead and run it and see if it works. So if we run the command, what is the focal length? We'll just make up some numbers here. Let's say the focal length is 25 again. Measuring in height or width, we'll measure in width. And then what is the object width in millimeters? So let's say it's, I don't know, 1,000. Let's say it's a meter wide. What is the object width in pixels? Let's say it's only 100 pixels wide in the photo. Calculating according to that on my camera with that photo, the distance would be 58,000 millimeters away from the camera. Although as you can see here, we did accidentally turn the rest of the text purple as well because we forgot to change it back to no color. So maybe you don't care about that, but I do. So we're going to go back into here, and then after the distance millimeter, we're going to add the no color parameter, which will change everything back to no color, and we'll also use the normal variable to make everything not bold. And of course, we'll need to do that in both parts of the if statement. Now, if your code is not working, just go through and double check that all your variable names are right. There's a lot of different variable names, so it's really easy to mess those up. Also, make sure that all your brackets are lined up with each other. That's another really common mistake. And if you can't figure out, just Google the error code, and I'm sure someone else will have some ideas, or leave a comment down below and I or someone else will probably be able to help you. Okay, that is it for the script of the math. Now, you can do a lot more with this script. I highly recommend delving into Bash. Bash is a great great programming language to get into because it's so useful in running math and just basic stuff on your computer. Bash can do so many things on your computer. It can open and close applications, it can type things, move windows, it can do so many different, actually I don't know if it can move windows, but it can do a lot of things. So I really recommend just diving into seeing how you can use that. It's really cool to be able to create a script that would normally take you a long time to do on your computer. You can do the same thing with a script usually. That's going to be about it. You can also, with this particular script, I have worked on it more, and you can do a lot more things, adding more options for variables, adding more if statements. You can really make it quite complicated if you want to, and make a pretty cool terminal command line based application. Alright, that is going to do it for today's video. Go ahead and check out part 2 up here when we go ahead and test all this code and see how accurate the calculation is with measuring distances with your camera. I'm Josiah, thanks for watching.